Welcome back, everybody. We're beginning our new unit, Unit 6, on exponents, power, and logarithmic functions. What we're covering specifically today is what is repeated addition, what is repeated multiplication, and then the exponent rules specifically for today are the product and quotient properties. The first thing you have to understand is multiplication, and that multiplication is actually repeated addition, which means you are doing it over and over and over again, but you might not actually understand what that means. So I have a picture over here on the right-hand side with a bunch of stars in it, and what I want you to be able to do is tell me how many stars do you see without counting every single star. What you should have done is looked and gone, well, how many do I have in, say, a column? I have four stars in this first column. And if you add that up with the next chunk, so we look at this column here, I have another 4, and then I have another 4, I have another 4, and one more group of 4. So we have 1, 2, 3, 4, 5 groups of 4. So we have repeatedly added the number 4 over and over and over again. And you should have gone, well, 4 plus 4 plus 4 plus 4 plus 4 gets me 20. That should have been one way of looking at it. You repeatedly added. Another way you could look at this is instead of rows, columns. Say, all right, well, I have a column at the top. Oops, sorry. This is actually a row. So the row at the top here has 5 stars in it. This row has 5 stars. This row has 5 stars, and this row has 5 stars. And then you can say you have 1, 2, 3, 4 rows of 5. So if you repeatedly add 5 over and over and over again, you're also going to get 20. 5 plus 5 plus 5 plus 5 gets you 20. So you should have done a repeated addition type of thing in order to count how many stars were here without really realizing it. So what you were really doing is just multiplying 4 and 5 together to get 20. Another thing or another way to think about repeated addition is look at these two expressions that I have here, 3x and x cubed. You should be able to tell me the difference between these two things. Go ahead and pause the video for a second. See if you can actually explain what is the difference between 3x and x cubed. Well, I'm going to tell you here. So 3x, if I expand that, if I pull that apart to explain what in the world that is, it's actually x plus x plus x. So over here, I just expanded 3x. So we took those x's and just said, oh, well, we have 3 of them. They're being added together. X cubed, if we expand that, if we pull that apart, that is actually x written 3 times with multiplication. So the difference here is in the representation of addition and multiplication. So if x is being added repeatedly, we can shorthand that by using multiplication, just like what we did with the stars. Instead of doing 4 plus 4 plus 4 plus 4 plus 4, we just said, well, what's 4 times 5? Instead of doing x plus x plus x, we said, what's 3 times x? Same thing with exponents. So this box down here, instead of saying x times x times x, we can just say x cubed. That little number up top here just tells you how many times are you multiplying that variable or that base by itself. I'm going to look at a few examples here. So exponents are just the faster simplified way to write repeated multiplication, just like multiplication is the faster simplified way to write addition. So we're just getting more and more collapsed in on each other. So a simplified way of writing it. So 3 times 3, well, we could write that down as 9, but what if I wanted to write it with an exponent instead? How would you write 3 times 3 with an exponent? Well, I have 2 of them here. So instead of writing 3 times 3, I could do 3 squared because I have 2 of them. Same thing with x's. Instead of writing x times x, I have 2 of them here, so I could write x squared. The little number up top tells me how many I have. Even though in this third example down here I have different variables, you can still use the same approach. Just stick with your like terms. X's are the same, so focus on those. We have 2 X's here that are being multiplied. So you should already know what that's going to get you. And then we have a bunch of Y variables. Those are all like terms that can also be written separately. And we have 3 of them. So think about how in the world would you write that with exponents? We have 2 X's and we have 3 Y's being multiplied. So you should get X squared and Y cubed because we have 2 X's and 3 Y's being multiplied. This final one is actually a little tricky. Be very careful how you write this. So we have 3x times 3x times 3x times 3x. We are multiplying the exact same thing 4 times. So we wrote 3x 4 times down here, which means you should have a 4 as an exponent, but be very careful. Do not just do 3x to the 4th power. You should put parentheses around it because both the 3 and the x were written down 4 times. So that little number up top just tells you how many times are we multiplying this together. The next thing I want you to just know is what's the difference between expanded form and exponential form. So on this slide, I'm going to show you expanded form. That just means we're taking something compact and pulling it apart. So if we stretch it out, what does it look like? So something like 2 to the 5th, if I want that in expanded form, I'm going to stretch it out and just say, oh, well, that's 2 being multiplied by itself 5 times. So 2 times 2 times 2 times 2 times 2 is the expanded form. Same thing with exponents with variables. So we have x to the 3rd y squared is the compact form. We actually call that exponential form. X is written down 3 times. Y is going to be written down 2 times, and this is all multiplication. So x times x times x, there's your 3 x's, and y times y, there's 2 of them, and all of it is multiplied. That's expanded form. Exponential form is just the reverse, so if I give you a bunch of numbers and letters all thrown together in this mass of an equation, you should be able to squish it together into exponential form. So instead of 5 being multiplied 3 times, just say that's 5 to the 3rd. Instead of x times y times z, well, x can't be combined with anything, so it just stays x. Y can't be combined with anything, so it stays y. But z, we have 2 of them, so instead of writing z times z, I wrote z squared for exponential form. The next piece that I just want you to understand, because I'm going to be saying this a lot, is what does the word base and what does the word exponent mean? So base of an expression just tells you what number is being multiplied, and the exponent of an expression tells you how many times that number is being multiplied. So my example down here, I have 5 to the 3rd. The base is the 5, it's just the number 5, and the exponent is 3. So that means 5 is the number that's being multiplied. 3, that's how many times you're multiplying it. So this is really 5 times 5 times 5. The last 2 things that I'm going to show you in this slide are the product and the actual quotient property, and then you'll be able to click to a different video to actually practice some examples. So the product property, well, first thing you should know is what in the world does product mean? It actually means multiply. So that should clue you in on when to use this. The product property is used when like terms are being multiplied. And in short, what you're going to be doing is adding the exponents. So this seems kind of scary right now, but write it down and just hold on to it. But the definition of the product property is actually this. For every non-zero number a and integers m and n, so that means a can't be 0, it can be any number, but it can't be 0. And integers, you guys should know what those mean by now, m and n. If you multiply a to the m and a to the n, that's the exact same thing as a to the m plus n. Notice how my base never changed. The base stayed a. but it just took your exponents up top here, m and n, and said, all right, add them together. So write that down. You'll see examples in a moment. You should also know quotient property. The word quotient actually means divide. The quotient property then is used when terms are being divided. So in short, what you're going to do with this is the exact opposite of the product property. For every non-zero number a in integers m and n, same start as the product property, if a to the m is being divided by a to the n, that's the exact same thing as a to the m minus n. Notice again, I have the same base, a, but then my exponents are being subtracted from each other. So just think about it this. Product and quotient are opposites of each other, multiplying and dividing. They are opposites. So when you add the exponents for product property, it's the same thing as doing the opposite for quotient, subtract. So just keep that in mind, write these down, and then make sure you click the link to the example video next.